Hey guys, first of all, thank you for listening to the EduData podcast. Timothy and I have a great time talking about numbers and breaking down data for you, but we want to invite you to come and hang out with us. We are starting a webinar series, one per month, where we do essentially an episode of EduData via webinar with visuals, with our faces, and hopefully with you there to hang out with us.
You'll be able to log into the webinar and we'll have some more visual presentations. You'll be able to hang out and ask questions and have a more conversational format. So if you're interested in that, definitely check out our new webinar series. You can find registration information in the show notes or on enrollify.org.
Don't worry, if you can't make it to the webinar, that audio will be dropped on our podcast feed and available just like you access EduData now. Welcome to the EduData Podcast, a podcast that serves as your weekly guide to the data driving higher education. We are your hosts. I'm Jamie Boggs.
And I'm Timothy Davis. Join us every Friday for weekly breakdowns of the most important data, trends, and topics in higher education.
The EduData Podcast is a part of the Enrollify network, a robust collection of podcasts designed to help higher education professionals like you grow. Explore our other shows at enrollify.org or check out some of my personal favorites linked in the show notes below.
Enrollify is made possible by Element 451, the leading AI-powered, all-in-one student engagement platform, helping institutions create meaningful, personalized, and engaging interactions with students. Learn more at element451.com.
Well, hey everyone, and welcome in, and thank you for joining us for this afternoon session, Connecting the Dots, Visualizing Your Higher Ed Data Relationships. I am Erin Fields, and I am your moderator and the marketing manager for Enrollify here at Element 451, and we are thrilled to have you here.
Thank you, Erin. Like she said, we're going to try to share some insights that we've had over the years that's just going to hopefully make your lives a lot easier. We're going to talk about how an ERD can change your life and just make everything simpler when you're trying to put your life together, and more powerful and more efficient. Timothy's going to walk through an activity of how to create an ERD really quickly and also really effectively to make sure that you're putting all the pieces together. And like Erin said, we will have some time for Q&A. But as far as how an ERD can change your life, what does it even mean? That's an entity relationship diagram, which if you're talking to anybody else about this, you can call it an entity relationship diagram. It makes you sound smart.
Creative parties.
Yeah, it is. You can call it an ERD if you want to work efficiently. Don't call it an ERD. I've found that really kills the party. That's not a thing. Don't call it an ERD. So what is it exactly? This is a diagram literally that just shows the connections between your data sets. On our campuses, we have data in different systems, in different formats, in different softwares. And this allows you to visually see, how does this set of data connect to that set of data, and how can I use those effectively? And we're going to go over several examples. Here's just a super basic one of joining a course to a student, and that can be based on student ID, course ID, whatever you have in your system at the time. But you probably have seen these if you've been on board with getting any new softwares into your system, any new data tracking. And some of these can be super simple and super helpful, and some can be way overly complex. And we're going to try to help you avoid doing it in a complex way that's not super helpful. Why is this important? It's not typically part of becoming a higher ed person. When I went into higher ed, I had some stats classes in graduate school, but most of that was taking one data set and just doing some analysis on it, just finding some Z-scores, p-values, whatever letter they threw at me at the time. But it's not something we really learn. You learn how to talk to students. You learn effective communication. You're trained in all those things, but not, look, we have all this data. Let's put it to good use. So we want to talk to them about that. We constantly hear people say they want to learn more about data. In last month's webinar, we went really deep in the weeds on some linear regressions and some chi-square analysis. It was a really good time. Today, we are going to take a couple steps back and be more broad in how we talk about data. The students have data from all kinds of different sources and all kinds of um, different schemas, which we'll talk about here in a minute. But putting that all together is really going to help you to level up your skill set as you're looking to better serve, better recruit. Because not only are we just trying to put your data together, when data comes together, it tells a story, and it tells a story that can be super powerful in the way that we translate that into communications, into uh, different workflows that help us to be more efficient. So, putting this data together is more than just making the data talk to each other. It gives us a new paradigm on how to do our work.
Yeah, I think we could actually kind of dwell on that for a second, Jamie. We probably got some time here. I think that this exercise of creating an entity relationship diagram is also really helpful to just sort of demystify or take data out of the abstract. We tend to talk about the capabilities of data and what it entails in really abstract and vague terms. Um, and that can be kind of confusing when you don't have a background in it. If you start throwing around terminology like ERD, and your fancy other acronyms and stuff like that, it's not concrete. And this exercise, this is something that you would encounter in like a introductory computer science or database design course, and basically like defining how we want to represent the real world in data. Right. And so when we start talking about entities, and that's what Jamie's getting into here, we're talking about how to model the real world in the data that we store and talk about the relevant data that we should store. Right. So if we ever have a question about like, do we capture this? Do we capture this attribute of a student? Do we know XYZ about them? Well, did we plan to capture that about them? If this is something like student type, that's really common. What kind of population do they fit into? Are they a freshman or a transfer? But something that's more psychographic, like do we know, what their favorite TV show is? Do we know, it's stuff like that about them that's less related to higher ed and more about their personality. If we didn't model that out in our database, we don't necessarily have a spot to store it. And this entity relationship diagram exercise is how you kind of lay the foundation for capturing those things that you care about. And again, modeling the real world in the data that we store.
Yeah, and if you've ever worked with Element 451, in our import and export module, you have to select what data object you want to repeat on. So essentially, I want a row per student, a row per course. You can see the list here. What kind of data you have on campus. Some of you are on community colleges, and not only do you have your campus data, you have system-wide data that you're looking at, and different campuses are using different softwares, and communication is different between campuses and like in the system office. So it can get really complex really quickly. So what you need to do is just simplify this. I know I have this data, and I know it is all based on the student. So I have one row per student, and I know what I'm looking for. Now, the issue comes in when you have one row per student, but you're looking at something that relates to a high school. Now, you may not have, let's say you're trying to relate a course that a student's enrolled in back to a high school. I don't know why. That's your problem, not mine. But this is kind of like a 6 degrees of separation thing. Kevin Bacon has never been in a movie with Vin Diesel, but I can get there, right? Spoiler alert, Dwayne Johnson's and everything. He can get you there. Same way here. I may not be able to go from course to high school, but if I have this relationship diagram, I can see, well, if I have a course, I know who's enrolled. I can look at the student then. Once I have the student, I can look at the application, and on the application is the high school. And that sounds like it's a lot of steps, but if you get in a place where you are uh, uh, coordinating that data and it already exists in those formats and it already has the common keys, those IDs to connect those data sets, then you can get from one to the other really quickly without a lot of hassle. Or building out dashboards, building out diagrams of those things becomes really easy if you can just get a picture of how that data looks. Where is it? We talked about this CRM, SIS, LMS, spreadsheets. I continue to be surprised by this. I say that, but I had all kinds of spreadsheets on my office when I was the director of a TRIO program back in the day, and that's where most of my data was. Or we used student or Microsoft Access, which has come a long way. Was pretty archaic back then. You may have some kind of custom data warehouse on your campus, which again, that could be a great thing, and that could be a very complicated thing depending on who owns it, how it's managed, and so forth. But having a structured database on your campus, somebody who is responsible for campus data and putting it in all the right places with those connecting keys and able to show you the relationships is kind of the ideal piece. And not only are we talking about your campus data here, but if you look outside, if you're looking at IPEDS data or research data, demographic data, it's so easy to be able to connect even an incredibly complex data set back to whatever data you already have so that you can gain better insights. And the data is everywhere. It's in all kinds of different systems, all kinds of different formats. So today we're going to talk about bringing it all together. What are the keys to putting your data all in the same place in a usable way where you can gain those insights and you can start to put it into action? Like, knowing stuff is great, but unless it's leading to action, which you can use that data to then prove the success or the to pivot on what you're doing already, the data is there to help you make those changes. Now, before we get too deep into the diagram piece, I just want to take another step back and show, data, it sounds complex, and it can be. It can be super complex. But no matter what data set you're looking at, it's really a table. Now, it may be repeating on a different item. It may be organized in a different way. The cells can have, they can have numbers, they can have text, they can be binary, they can have arrays of data in the text. That can get more complicated. I don't know how much Timothy's going to go into. To be honest, he didn't talk to me too much after I put that High School Musical gif in there, so I don't even know what he's going to talk about.
Oh, you mean one of my favorite movies of all time, The High School Musical? That one?
No, yeah, I knew that. I just wanted you to say it.
Yeah.
Yes. But we're just looking at tables upon tables, rows upon rows. This is a sample of Element 451 data. Highly recommend living your life in dark mode. It helps your eyes and your headaches quite a bit.
Oh man, yeah, dark mode.
But yeah, no matter what we're talking about today, that data is in a table. We're talking about getting those tables to talk to each other in a way that's effective, efficient, and can tell a story. So don't get intimidated when we start talking about all the different blocks in this ERD. They each represent data sets, which are built in tables, which everybody can use. So it's trying to demystify the complexity of it there. Anything to add, Timothy, before you and Elmo?
Is it activity time? Yeah. Elmo. I actually used that gift today. Did I use that with you?
You did, and I had thought about taking it down, but
No. You got to leave it up. That's an amazing gift. Yeah. So just to follow up on what Jamie said there, right? An entity in that entity relationship diagram term refers to some sort of database object. Usually that's going to be a table. And that table is going to represent something in the real world, like a person, a student. And each row of that table is going to be a unique person, usually, right? Or a unique application or a unique thing. So for our activity today, we're actually going to pretend that we're designing some higher ed software from the ground up. And we're in like our second or third meeting, and it's time for us to design our database. So to start with that, we're going to make our own entity relationship diagram today. So warm up your typing fingers. Get in the chat, whether you're here with us on Zoom or on LinkedIn, those will make their way over to us, and type out some of the nouns that you use every day related to your job. I gave you one there at the top, student or person. There's a noun. Hit me with some other nouns in the chat. I'm going to start jotting them down, and I'm going to start sharing my screen as you're typing. Credits. It's a good one. Okay, I've just got good old text editor here. I'm going to put person, student, parent, type, course, credit. So many are coming in. Graduation year. rate, admit, conversation, high school. Somebody was paying attention to the slides. GPA, SEEB, student type, major, transfer institution, previous
There's some
institution.
other testing on this list. Funnel stage, conversion, international status.
Okay, that's a good list to start with. First, I'm going to take out some of, or I'm going to try to group these rather by things that have that are like associated with each other. So the first one that I'm seeing there, high school is associated with GPA, is associated with SEEB, is probably associated with, and probably not transfer institution. And that's associated with graduation year. I'm just jotting some of these down. Let's see. Person, I'm going to say that one's probably related to student type. Application, that one's going to be related to major. Term, course is going to be related to credit. Where do we want to put funnel stage, Jabo, just for our exercise today? You think that ought to go on the person, or should we put that in its own entity?
I'd put it with application, major, and term.
Yeah? Okay.
Let's do that.
Because we could call that like would prospect fit in there? Yeah. So I'm just going to put stage. Stage. So that could be funnel. That could be admit stage. That could be decision stage. However you want to think about that. Okay. Student, or sorry, person is going to be related to student and parent. Those are two different types of persons. We could maybe have a column that says this particular row is a parent or is a student. Okay. A conversation. That, I'm going to say that one's its own entity.
I would think so.
And conversion, would that be an activity? You reckon?
Mm-hmm.
Conversion, that'd be like got to spell. Is my keyboard clacking? Is it coming through the microphone? You're not hearing it too bad? Okay, I got it in my headphones a little bit, so I'm worried. Clickety clack. Okay, so basically what we try to do here is we try to group some of these nouns together into things that are associated with each other. And I'm going to expand this screen so that we're all in one line. So it looks like we've started to identify some pretty meaningful entities here. So each entity in our database design is going to correlate to like one table in our database. So we would have a table for person where we would, and I'll just put this like a person type, parent, child, student. I'm going to take that one out. We would have an application table, a courses table, a conversations table, a conversions table. So now that we've got some entities defined, we need to understand how they relate to each other. So this is where we're going to put together some verbs. So back in the chat, looking at these entities, to structure them in a phrase like person has application. That's the easiest one that sticks out to me. Any other ways that these things can be related? So has being the relational term there. Any others that stick out? I'm going to wait for the chat. Jamie, you want to offer one up? Keep us moving.
Yeah. So verbs. Oh, I'm a math guy. See, come on, bro.
Right. Yeah. Student has GPA. Thank you. I'm actually going to call that a person has GPA because
obviously person from high school, that's not a verb, but graduated at a high school, graduation year, graduate's a verb. Student earns credits.
Person earns credits.
Lead becomes inquiry. I don't know if those are the ones we have up there yet.
Someone just offered this one up in Linnell said person visits campus. Ooh. So that could be here we go. I would say let's put that one as part of the conversion, because visiting campus is itself what we could call that a conversion. So we could say the conversion table is going to have a conversion type column that'll be like campus visit, RFI, etc. And that is a meaningful action that they take. So we would say person
has conversion. Person submits form. I'm going to keep that one in. Person has conversion. Person applies. I'm going to say that would be person has application. I'm going to put that in the same. Person selects major. Okay. That would be an interesting way to carve that up. So this is where we could talk about how step away from our example here and talk about how database design decisions have been made in currently. Most of the time, major selection for a applicant happens as part of the application. So if we imagine an applications table where one row is an application, a student can have multiple rows in this table. So we would have a column that says this application belongs to this person. And then per application, we would typically see they have a major, they have a term, they have a student type, etc. So that would be an attribute of the application. But just to explore this possibility, if a person, if we wanted to, we could design a separate table for, say, like major selections. And a person could have multiple major selections. And a major selection could both be associated to the person and perhaps to the application. So maybe they select two majors that they want to intend for as part of their application or apply for, something like that. So we could do that. I think that that design decision hasn't been made in the past, but it doesn't necessarily mean it couldn't. For simplicity, I'm just going to keep it, and real world application, I'm just going to keep the major as part of the application. So that would fit here and has application. Application has major. There we go. So now I'm seeing that latest one from Mike. So just to close the loop here, everything after this hyphen or like each of these items related to the application, we would call that an attribute of the application. So if it's a column in our applications table, that would be an attribute, right? So just to clarify terms there. There was one, person submits form, person enrolls. That would be, so we could talk about, we could do this in a couple of ways. We could say person enrolls in course. That's how they relate there. We could also say person enrolls at institution. So an institutional enrollment and a course enrollment. They're a current student and they're enrolled in this course. So that's how we would relate those two things. But here we have a new noun, institution. So we'd put that here, institution. That would have attributes like address. What else? What else is an institute? Logo, mascot, any other institution, campus. There we go. But here we go. We could add another layer here. Campus, that could be its own entity that relates to the institution. So we could say institution has campuses. This one I'm just for the sake of keeping it with what we've defined up here, has high school, or we would say attended high school, something like that. Okay. Anything else in here that you think is particularly relevant, Jamie, or anything else from the chat? If we've had anything, any glaring nouns that are missing here that we'd like to explore.
I think that's a great start.
Yeah. I think for simplicity's sake, we'll keep it at that. Okay. So the next thing to do from this is we've kind of defined some entities. We've defined how they relate to each other. And now we can start sketching out a graph. But I don't have a lot of time to get into what PowerPoint and create a bunch of shapes and like tie them together. So I'm going to use ChatGPT to do that. And we actually could have even backed up and asked ChatGPT to list us out some nouns and verbs. But I'm just going to use it to create a diagram for us. So in ChatGPT, I'm just going to paste this in here. Here is a set of entities and how they relate. Help me make a ERD so I can visualize this. So before I hit enter, I am going to type one more sentence, but I'm going to explain why I'm doing this. My experience with ChatGPT is that when you ask it to generate like an image of something that's structured, like a diagram, or if you ask it to like draw it, with like a digital tool like an SVG, which is like a vectorized image, it can write the code to do that. I've never had a ton of success doing that. And so when I want to create diagrams or like structured visualizations with ChatGPT, I ask not for it to draw me the thing, but to use some structured language that that it can output and do so more consistently. Then take that structured language, which is a set of instructions for some diagram tool, and pop it into the diagram tool itself rather than trying to let ChatGPT replace the diagram tool, if that kind of makes sense. So what I'm going to ask it to do is I'm going to ask it to format in the mermaid language. Bet you didn't know we were talking about mermaids today, Jamie. Yeah. So if you've ever worked with like a metadata file, as part of a database or for whatever other purpose, a metadata file it contains instructions for some computer tool to run. And so the mermaid language is a markup language, a structured language that was designed specifically to be used to create entity relationship diagrams. And so in my other tab here that you might see on my screen, I have a flowchart and diagram tool open that I can just paste these instructions into. Format as a mermaid file. Thank you. Did you see they had a press release the other day, OpenAI did, where what's the guy? Sam Altman was like,
Yep.
The please and thank you accounts for like millions of dollars of credit spent. Don't change a thing. Always say thank you.
Worth the price of staying on the good side of the robots.
Amen. All right. So now we have this thing here, which is a markup file, which ChatGPT generated for us very kindly. And it looks like it has defined the relationships up here. So it's showing how they relate to each other. We don't necessarily need to understand it perfectly in order for it to work. And then it defines a couple of other relationships here. Cool. And then within the entities, it's defining some attributes. So the person has a person ID. Excuse me. Whoa. Has a person ID, has a name. Application has an ID, has a submitted date. We'll edit this as we go. But I'm just going to go ahead and copy it, and I'm going to pop it into my tool here. So this is the mermaid.live, which is a visualization tool that's free. Just open it up here. I'm actually going to open this up in another chart. And are we seeing that? So now, based on the structured output that ChatGPT gave us, I just copied that straight in, and now we have an entity relationship diagram. And we can see how these things relate to each other. So these markings here indicate the type of relationship. So let's see, a person can have multiple credits is what we're seeing here. So they can have multiple credits per course. Did we, it looked like it actually separated those out. Oh, and then it made up course enrollment too. We hadn't talked about that. Okay. And then another thing it did here is it has high school attendance separated from high school. So that would be like if you had a table that lists out high schools and then a table that lists out a student's attendance of a high school. Mm-hmm. But you can even see it in the description or in the visualization here. These are just the tables. These are the tables that we are repeating on. So within that, within this configuration here, we can say the high school has a, can I type string? It's going to be a SEEB. We wanted that one. Over on the application, string major, string term, string date. These are all just the types of columns. So a string is just text. Date, of course, that'd be like a date or a timestamp. An INT, that's going to be an integer. So when you start talking about databases, each column has to have a data type. It can be a number. It can be a number with decimal places. It can be a text field. It can be a text field that is enumerated, meaning there's only a few valid options. So like term would be a great field to have enumerated because you only want, person to select from fall 24, fall 25, spring 26, whatever. You don't want them to write in, spring of 1892. Is that a significant year? I just made that up.
Not to me.
Probably nothing happened to that year. Okay. But now we have gotten to a place where we've got a good understanding of what our database is going to look like. So that I think concludes our activity for today, let's talk a little bit about how to use this, Jamie, with the last few minutes that we have. And as you're listening to us talk about how to use it, if you've got questions about how this is applicable to you, or questions about how this came together and how this would apply to a specific situation or a tool that you use, we'd love to talk about that as well. But my first takeaway for how to use this is that understanding how this database design process works, and how it kind of comes together like this is helpful when you're wanting to understand how your tools work. You can take these same concepts and map them back to the tools that you use, whether that's your SIS. I've been working in Colleague and Banner a lot recently. Colleague and Banner are both relational database systems. So we've got multiple tables of different things that all associate to each other. And when you're trying to locate an attribute or figure out how to store some data somewhere, right? Understanding where it's going to go and how to think about it, what entity to relate it to can be really powerful.
Yeah, absolutely. And like I said, I made the joke about 6 degrees of separation, but a lot of times you can look at a data set and say, well, with the campus object down there in the bottom here, which you can see exists kind of independently, in our terms in element 451, that would be like a data source that you're pulling from. You may say, I have no use for that. But once you see that I can tie that back to everything else, it creates a more holistic picture of the enrollment funnel, of when we're talking about retention, like what factors are going into retention. I didn't even know I could talk about somebody's grade in sophomore geometry and how that may have an impact on their summer internship after their sophomore year. Like it sounds silly, but you could connect anything, and whether you're looking for analysis or you're looking for best practices, or you're just trying to aggregate data to try to show somebody, hey, this is what we're dealing with. And this is, I mean, I don't think you can overstate the usefulness of a tool like this. And to be able to do it that quickly, I mean, just think about the amount of time it would take to construct this manually. And then make sure you're getting all the fields correct and that kind of thing. It would be a big headache.
Yeah, for sure. And one of the examples, the use cases that comes to mind where understanding this is really helpful is when you're creating new columns, or trying to collect new types of data, right? So one of the things that I've experienced recently is a common question at Element is how do we store an applicant ID versus an application ID? And are those the same thing or are they different? So sometimes we want to put the application ID on the person. So that would be like the identifier for the application on the person. Well, that person can have multiple applications. So if they come back and we try to write a new application ID to the person, we overwrite what was already there, right? So that's a common thing, is finding the right entity to put your new data on. Did we get conversions? Yeah, conversions got placed in here. So if we wanted to collect more information about different types of conversions, or whatnot, we might like extend this out into, other conversion types. So we want to know like what web page they were on when they submitted a form, or we want to know
what social media channel they came from, what app they clicked on. A lot of marketing pieces can be supported through this.
Oh, great question from Lindsay. What does PK mean? So yeah. So that's a database term when it talks about the like unique key or the unique identifier per row. So that it stands for primary key. And so like in your student information system, your student ID, that is the primary key for each person. So when they have an email now and they have a new record in Colleague, for example, they are assigned an ID. That ID is their primary key. And then when we have relationships between multiple entities, the repeating entity will usually contain the foreign key for the entity that it relates to. So if this course enrollment relates to the person, it will store as an additional column in this table the foreign key for the person that it relates to, and that would be this person's ID. Great question there. Jamie, you have anything to elaborate on that?
Nope. I was reading a couple more questions coming in. Jasmine asking more about marketing pieces. this would be a great way to visualize, like I said, the marketing channels that individuals are coming from. But you could even put, if you wanted to put um, the different pools of individuals together to show kind of the funnel stages of, we know we had this many individuals come from TikTok, and then however many of them ended up in this other place. How do I find out how many students from Facebook now major in geometry? Like, you can do that through this. Um, Obviously, that's past the point of conversion and application and admission, but you can even back it up to which students are coming from certain channels that end up enrolling. Maybe you're getting a ton of inquiries from Instagram, but nobody's actually coming. So I think you can back that up and just connect pieces a little bit more across the board. Maybe you're seeing that you're getting mostly nursing majors from LinkedIn or wherever that may be. So tying those pieces together can help you to focus your efforts in certain places.
Right. So like, if we were doing like an analysis of conversions, we might want to pull in attributes of the person, or even attributes of the person's high school or of their applications. And to do that, we would aggregate applications onto the person. We would aggregate high school information onto the person, or high school attendance onto the person. And then using the foreign key of this conversion to say that it associates to this person, using that foreign key, we would join all of those persons' aggregated attributes onto the conversion and say each conversion, we have X amount of conversions from people who major in biology or something like that.
Yeah, and Kevin asking, and this is not unique to you, Kevin, but just about bringing pieces that are focused on the student, but from many different areas, for many different programs like Colleague, Element 451, Canvas, Azure. So I think there are great ways to do that. I think that starts with being able to match up keys from each of them. You just have to have something that ties the student record in Colleague to the student record in Canvas. That could be campus email address. That could be a number of things. But as long as you have those pieces that make those connections, then you can certainly do that. And you could make an ERD that looks like this. It would probably all be joined together by similar keys, but it would still allow you to see, maybe you're wanting to see which systems have which fields. I think that would be wonderful to see if you had an item on an ERD with a specific software, and then you have a list of all the fields with the key in there, and do that for all of them. Be like, well, I know if I want to look at academic information, then whatever is not going to give me. I didn't want to diss any of the softwares there. I was going to say this one's not very helpful, but they're all super helpful, right? Especially Element 451. But that way you can see where to go to for certain information types or topics or subjects.
Yeah. I mean, if I was going to extend this exercise out to, the multiple systems, right, you would create, an entity relationship diagram, or you'd find an entity relationship diagram from each service provider or each platform, and then, kind of lay them all out together and then identify where they can connect to each other. So for higher ed, the primary the entity is usually the student. Right? Your CRM is going to recognize a student. Your SIS recognizes a student. Your LMS recognizes a student. Your marketing tool, whatever that is, if it launches campaigns or whatever, it recognizes a student. And so once you've got your entities for those different systems laid out, you can also find ways that they connect to each other. You can even do an intermediary table, that says like, here's a table of identities for students across multiple platforms. That might be something you had to create manually, but would certainly be a way that you could create those relationships.
We had a couple questions here, Timothy. How would you handle a situation where a parent is using the same email address and filling out RFIs for two different students?
Yeah, so that's a database design question for sure too. I mean, we certainly encounter that in Element where students maybe don't have their own email. And I think Lindsay is recognizing that as well, that's something that we in Element try to figure out. That one's a difficult one to get around. I think, talk about the difference between the way Element was designed and the way that other systems are designed. I think in some SISs, email is actually treated as its own entity, and an email address can be associated to one or more people. And so in that way, it's not a unique identifier. But from Element's perspective, just to speak about Element 451, because Jamie and I both work there, we treat email address as a unique identifier, as a primary key, as one of the many primary keys that a given person can have. So yeah, you do run into problems where a parent will try to create a record based on the same email address for two individual students. Yeah, that's definitely a problem. I don't want to get too much into like how Element solves for that specifically, but yeah, just to kind of give an example. Yeah, there we go. Katrina shared an example there. You can prompt them to make the email unique, but stay routed to the same address. So most email providers, and now we're getting into kind of some niche knowledge here, is most email providers will allow you to modify an email address with a plus sign and some additional characters before the @ symbol. So like my email address at Element is timothy.davis@element451.com. I can add a plus sign between Davis and the @ symbol to be able to, do I have this open right now? This is exactly what Katrina shared. So from this and this are technically two unique emails from the perspective of a database, but from the perspective of an email provider, they're the same. So they'd route to my inbox in both cases, but from a database's perspective, they're unique. So they can be done that way. You could potentially prompt parents to add a plus for like the student's name after the email or something like that, but that would have to be done in like the help text. The only difference is their middle name's Mike. I don't know how you solve that one, man. That's a tough one.
Is that our next webinar, Admitting Twins 101?
Admitting twins. That's we got a whole hour on that. Yeah, the exact statement was good luck when they have twins and the only difference is their middle name. Yeah. So that's a tricky one.
In 1892, St. Petersburg, Florida became an incorporated town. The diesel engine was patented, and the first basketball game was played in public. You knew it was so.
Yeah. I've got that. I've got that year bookmarked for sure. So. Yeah. Well, Aaron, do you have some follow-up for us?
I do. You're gonna go back to the slide deck real quick and verify that it's you?
No, I'm not doing that right now. Jamie, save me.
1 moment.
Jamie coming in to save the day. Well, I hope you guys all join us next month for our next webinar for the twin segment. I'm sure it'll be great, Timothy and Jamie. But on the horizon, we have a few different events coming up. One of those being a webinar by Element 451 about Bolt agents. So all about the digital workforce and Element 451 building out Bolt agents and how you can transform your campus operations in this 45 live minute demo. So be sure to register that with the link in the chat by Shelby. And then the second is the Engage Summit, which is pretty much like Element 451's Super Bowl. It's our signature event of the year, so sign up now before spots run out and hear from your peers on how AI is shaping the future of higher ed. Since you're at this webinar, use code Enrollify50 for $50 off your registration for the Engage Summit. But if we have any last-minute questions for Jamie and Tim or any parting thoughts, Jamie and Tim, before we close out this webinar here, I know we're about 5 minutes over time, but any closing thoughts or questions?
I just hope people are, if data is something that intimidates you, I just hope people get in a place where you don't just shut down and not pursue a worthy activity due to complexity of data. It is a worthy venture. The stories told are super helpful.
Yeah, it's absolutely something that everybody can get their heads around. I remember when I was, a younger person and had watched a lot of sci-fi, like, the idea of like big data, all the technology, everybody's saying the future is here, we're living it, this is Star Wars right now. Okay, well, I still don't have a lightsaber, but When I started to kind of learn about how databases work and how entities relate to each other and how to define attributes and scope those attributes and all that stuff, it's just like, oh yeah, okay, I get that a little bit more. It's not as monolithic, as I was worried it was. So, hope that's helpful.
Great. Well, thank you everyone again for spending your afternoon with us learning about data. And this will be a monthly thing from Jamie and Tim. So look out for in a few weeks for the next announcement for May's webinar. So thank you all and have a wonderful day.
Thanks, everybody.
The EduData podcast is part of the Enrollify podcast network. If you like this podcast, chances are you'll like the other Enrollify shows too. Our podcast network is growing by the month. We've got a plethora of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional.
Our shows help higher ed marketers and admissions professionals find their next big idea and feature a selection of the industry's best as your hosts. Learn from Jamie Hunt, Artis Cadu, Dustin Ramsdale, Jeremy Tiers, and so many of your other favorite leaders in higher ed. Enrollify is made possible by Element 451, the leading AI-powered all-in-one student engagement platform helping institutions create meaningful, personalized, and engaging interactions with students. Learn more at element451.com.